For this problem, we're given that a laser printer is rated at 90 watts at 115 VRMS. We know that we're going to be dealing with VRMS, so when we look in the notes below the like button, we know we're going to be looking at section 10.3, the RMS value and power calculations. We know that we have wattage right here, so this is going to be our power average, and this is obviously our VRMS. It's given to us right here. We need to calculate the RMS value of the current drawn by the laser printer, so the ipRMS. Well, to do this, we're going to look in section 10.3, and we can see this formula. We're going to use this bottom one right here because we want to find our IRMS, and it gives it to us as our IRMS here. We need to rewrite this a little bit. We need to have our power average divided by our R, and this is going to be all under the square root set equal to our IRMS. So this is the equation that we're going to use for our IRMS. Well, we know our power average, that's going to be 90 watts. So that's going to be 90 here. However, we don't know resistance, which is where we call upon this formula. We're going to use this formula to find the resistance. We are going to have to rewrite it a little bit. So we are going to set R equal to our V squared, this is VRMS squared, divided by our power average. Now we know our VRMS, it's given to us as the 115, and we know our power average. So we're going to just have 115 divided by 90. And before I forget to mention, the 115 should be squared. So we're going to have actually a 115 squared divided by 90. And this is going to give us approximately 147 for our resistance. So now we can plug this into our formula. We're going to have the square root of 90 divided by 147, and that will give us our IRMS. And if we do this, we're going to see that the value is 0.78 ARMS. So that is how we would solve for A. Now we're going to look at part B. We need to calculate the peak magnitude of the voltage fed to our laser printer. Well, in the notes just below the previous notes that we used to solve for part A, we are going to use this formula to solve for our Vpeak. Now, there's not really a Vpeak in here, but Vpeak is basically the topmost part. So that is basically the equivalent to our Vmax. So Vpeak is going to be equal to our Vmax. These are interchangeable and they're used interchangeably. So now this is how we're going to solve for this. We know that all of this is equal to our VRMS. So when we rewrite this formula, we're going to have our VRMS times the square root of our 2 equal to our Vmax. And that's how we would find our Vmax. We know that our VRMS is 115. That's given to us. And so we can plug these in and then solve for it. If we do this, we are going to get that our answer for our Vpeak is approximately 163 volts. That's how you go about solving for this problem. If you want notes for this material, they're in the description below. And if you want more network analysis problems, they're also in the description below the like button.